Hey, are you ready? Okay. 皆さん、多分同時通訳も持ってらっしゃると思いますけど、先に言っとくと、多分、日本語で聞いてるだけだと、多分、エリックの、トークに伝わらない部分もあると思います。っていうぐらい、今から始まるのエリックのスタンドアップショーなので、右の耳で英語を聞いて、左の耳で翻訳を聞いて、ちょっとノリが違うなと思ったら英語側の方に合わせてもらって聞いてもらえればと思います。はい。
All right. Konnichiwa. There we go. And that's all I know. So I did some training and I can order rice and water in a restaurant, and that's about all the Japanese I know. So I want to thank you very much for allowing me to come here. Who's this American who speaks no Japanese, and why in the world would he get to come speak to you? I gotta be honest, I don't know, but I'm pretty thrilled to do it. So, again, my name is Eric Johnson. Tell you a little bit about who that is here. See if we can get my laptop to wake up. There we go. This is me. You see it? Okay, it's me. Yeah. So there's validation there. That is me. I am a developer advocate for serverless at AWS. I've been with AWS for, I'm coming up on 5 years. Now, there's a couple of rules real quick I'm going to explain because we've already done a number, so I need to explain this. And first, I'm going to check with my translators. I got thumbs up? We're good. Okay, so I'm going to speed up now. No, I'm just kidding. All right. Okay. So, a couple of rules when I'm talking. And rules is probably a strong word, but this will help you. They're more like guidelines to help you out. The first rule is, this is any number I want it to be. Say it. Okay. This is any number I want it to be. Now, I will hold this up and I'll say 5, I'll say 20 or something like that, and it throws people off. And I do that, here's the honest truth, I do that because it confuses people. And Dan's here now. Dan and I went into a restaurant the other day, and I said, table for 2. And they said, oh, 1. 2. 1? 2. So this is any number I want it to be. The second rule is, these are quotes, not apostrophes. And I know that, okay? And finally, these are thumbs. All right? I do this because this will get you beat up. Okay? So you do this to someone, you get in a lot of trouble, right? I make a lot of one-finger jokes, and I'm okay with that. I was born this way. I did not wake up this way the first time this morning. If I did, I would not be sitting here with you. I would be somewhere else trying to figure this out. I'm very comfortable with one-finger jokes and how I am. However, if it makes you uncomfortable, I'm also comfortable with that. So I'm good. Okay, all right. So let's get started. Today, we're going to be talking about several things. Again, a little bit about me. I've been a solutions architect for over 20 years. All right, not 1, but 20 years. I'm pretty old. I've been a developer for 25 years. Now, I'm going to tell you, I remember the day Lambda came out, when Lambda functions were announced. And unlike Alex, I saw the vision, okay? That just really kind of tells you the quality of, no, I'm just kidding. I was one of those nerds when they announced Lambda, I said, oh, why would you do it any other way, right? So I was really excited about it. Now, I'm a father of 5. That's not a typo. That's real. I have 5 kids. My wife is amazing, so obviously. I am a drummer that used to say musician, but people are like, really? Are drummers musicians? Yes, we are. So, and if you want to know how that works, because I know right now some of you are looking at me going, I don't understand how that works. How would you drum? I'll tell that story later. But I will tell you this much, okay? I went to school to be a musician. I was trained to be a musician, and here's what I learned. that I am a phenomenal drummer for one finger. But past that, I'm pretty average and nobody's going to pay me to play. So there you go. And finally, I'm a foodie. Obviously, I love food. So, and I've been really having fun here in Japan. The sushi is amazing, and they're introducing me. We had a little grill. It was amazing. So your food is excellent, and thank you very much. All right, so let's jump in and get started. How many of y'all want to place bets on whether I fall down on this? So just keep an eye on it. So, all right, so today we're going to be talking about several things. So this is the AWS keynote. So I'm going to be talking about AWS and where we were, where we are, and where we're headed. And you've already heard, again, a lot about AWS. I love some things Alex said, most of the things Alex said, like a percentage. No, Alex is brilliant. I love what he had to say, and I agree with what he had to say. There's a lot of things going on. There's a lot of change coming in to the serverless ecosystem. So today we're going to talk about defining serverless. When you put 100 developers in the room and you say, what is serverless? You will get 103 answers, right? Because someone always changes it. It's very confusing. People struggle with what is serverless. So that's the first thing we're going to do. Number two, we're going to talk about trends in serverless. And finally, we're going to talk about the future is serverless and what I believe that to be. So let's jump in. So when we define serverless, okay, and you saw some of this with Alex, and you're going to see some of the dates are different. Alex was doing some of the beta releases. I do the GA. There's a little difference in the dates, but they're like when they came out and stuff. So back in 2014, we released this AWS Lambda, right? And this was kind of a big deal, right? This was the first service to be called serverless, right? But the interesting thing was, it kind of helped define serverless. It almost happened right there, all right? So there's four things. When we're talking at AWS, there's four things that we generally refer to when we're saying what is serverless. And the first is that there's no server management. And that's really where that core definition comes in. No servers to manage, so therefore serverless, right? And so that's the first thing. The second thing is this ability to scale. Now, when we talk about scale, if you're not familiar with serverless, at AWS, using EC2 instances or using containers or something like that, those scale too. We have auto scaling and things like that. But here's an interesting difference. With an AWS Lambda function, it can scale up to handle massive amounts of load, but then it scales all the way back down to 0. That's a 0, I can do 0, right? And that's a critical thing because that leads us on to actually the fourth one, which is you pay only for what you use. So this model kind of changed how we look at compute and how we do services, right? And then the fourth thing, and I jumped out of order a little bit here, is the security is built in. We handle the physical security of your servers. We give you tools to build security when you're building serverless services. Excuse me 1 second here. There we go. So, like I said, this was the first service to be called serverless, but it wasn't the first serverless service, right? As Alex mentioned earlier, you're going to hear that a lot in my session. As Alex mentioned, but we had several services that were already out. We had the Amazon Simple Storage, or what we call Amazon S3. We had Amazon Simple Queue service. You notice there's no logo for the Amazon Simple Workflow service. It's because it's not a service that we use anymore. It's actually now, we've moved to step functions. We have some companies that are still kind of grandfathered in there, but it's one of the first services we had out. And finally, then AWS Lambda came out on November 13th, 2014. So let's talk about why was this considered the first serverless? Why did it create that name serverless? And I think the real reason is it's because Lambda was the first compute. Up until this point, you had services that would do things. You could store things. You could build queues. You could orchestrate some things, but you couldn't run your code, right? You could just use the services as they were. So Lambda kind of broke that mold by saying, now you give us your code and we'll run that for you. Don't worry about the servers. Don't worry about patching, managing all those things. Just give us the business logic, give us the code that's core to you, and we'll run that when an event happens. Okay? And so that's what kind of changed this. And we can do it in Python, we can do it in Ruby, we can do it in you know, I could name them all. But and then we came out with this thing called a custom runtime, where we said anything you want to do can be run inside of a Lambda function with a custom runtime. So you could run COBOL, you could run Elixir, you could run, that's all the languages I know, I've just run out. But lots of languages inside of a Lambda function. Since then, we've added multiple serverless services. And these are not all of them. I just put some on the slide so you can see them. One is DynamoDB, which has been talked about. It's an incredibly powerful database. We have Amazon Event Bridge, step functions, and I won't list them all, but you kind of get this idea. These are services that enhance your ability to build applications by removing, we'll talk more about this, by being able to use a service where you would usually write code. Okay, and that's a trend we're going to talk about in a little bit, but I want you to keep that in your head. As developers, raise your hand if you're a developer. Okay, all righty. As developers, and I know you, I'm kind of a hack developer, but it says developer in my title, so today I'm a developer, right? As developers, we want to do everything in code, right? We tend to go, I can do it better. I'm going to build the next awesome authentication system. And I ask you, why? Because that's not, if that's the core of what you're building, if you're an auth 0 and you say, look, we're going to build an amazing authentication and authorization system, then great. But what happens is, as developers, we tend to put into our code a lot of stuff that takes away from the fundamental core of what we came to build. So that's what, at Amazon, we said there's got to be a better way. We should be able to pull these out and abstract them away to services. And that's what you're seeing here. Bus services, pub sub services, notification services. Down, all the green ones are AI/ML services. So you have a lot of flexibility. Rather than you having to write your own model, you can use one of these. So where does this take us? Now, the very last thing we've added is this ability to have more compute. Has anybody used Fargate in the room? Okay, a couple of you, great. Did you know that you can invoke a Fargate task from step functions or from Event Bridge? And so this gives you, I always see some people going, oh, hey, you have my attention. What we've done here is we've opened up the ability to say, if a Lambda function doesn't match, you can still use Fargate and it's serverless, right? You don't patch, it comes up, it comes down. So this is something that's very cool. It scales automatically, security is built in, and you only pay for what you use. It's a serverless container service. So that's kind of where, that's kind of from past up to where we are now, right? So we've got this, we've just added these containers, I have some words that I use in there that I'm going to explain as we dig in a little more. But what I want to talk about is now that serverless has been around for 9 years, we've seen some trends that are happening. I'm going to tell you what I've seen over in the US or talking to developers, actually kind of worldwide. This is what I have seen, right? And I talk to a lot of developers. So the first thing, when serverless, how many of y'all started building Lambda functions back when it first came out? Okay, so there's some early adopters, or pretty, for a while. You've been building for a while, okay? And I'm sorry to the translators, I use y'all. That's a Texas phrase for all of you. So there you go. So all y'all is all of you. So when we first, and I'm guilty of this, when we first started building Lambda functions, we treated them as like a lift and shift, meaning we would just pick up applications, drop them into a Lambda function, write code around it to handle the event processing, and then run that. And so what that meant is your authentication was in your Lambda function, your authorization was in there, your routing, your business logic, your whatever, right? Because we're developers. We don't use services. We write it ourselves, right? We're coders. And so that's what happened is we build these monolithic Lambda applications, and we would run things like Express in Node or Flask in Python. And you would run these applications. And that's not wrong. That's just a pattern that we've seen. In fact, that's a pattern coming back around a little bit today. But this is where we started. Then we looked at the system and we said, you know what? We should be more granular in how we build applications. We should spread this out. We talk about this thing called, it's basically, as a Lambda function, I should have one job, single responsibility, okay? One thing, and I do that one thing really well. So then we went the other way. It's kind of, you think of a pendulum swinging, we swung the other way, and we built what are called Hypermicro services. All right, now you can look this up. I don't think anybody else is calling that. That's what Eric Johnson is calling it, but I'm really pushing that. So tweet that if you can, Hypermicro service. No, I'm just kidding. So we built these applications where we would say for every route in our application and every method, so if you're thinking of a REST API, we would say for users get, we would have a Lambda function. For users post, we would have a Lambda function. For users, whatever. And so our application started looking like this, just a billion Lambda functions. Which, you know, at AWS, we're like, hey, great, thanks. We appreciate the business. But it became a management nightmare. It's really hard to maintain. Oh, what function? It's because it's all still code, right? And you're like, what Lambda function was that code in? I don't know. And then you could do like me and say, look, I'm an architect, not a coder, so good luck to you, right? So this is kind of where we swung. But now what we're seeing is folks are saying there's got to be a happy medium between the two. Excuse me. And so what we've done is we said, okay, the hypermicro services, that's a little too crazy. So but we don't want to go back to the monolithic. So we're going to find something in between. And this is what we call the blended architecture, right? So, and that may not be, again, the name. These are Eric Johnson titles, so they're obviously authoritative. But the blended architecture says, I'm going to do logical separation of code. I'm going to find a place, so let's say I break my application down to users, reporting, you know, fulfillment, I don't know, image, whatever. We can think of a bunch. And we say, I can break it down, and I have one Lambda function that handles users. I have another Lambda function that handles reporting. Or if those get a little too crazy, then I might start breaking it down some more. But there's logical separation. This gives you a lot of ability to maintain code and go to the logical place to find where that exists. Okay, but a lot of times, again, we're still routing inside of our Lambda function, but then we're primarily focusing on business logic. And this is used for, you know, we see this for web backends, we see it for EDA applications. And at this point, I want to stop for a second. When I say EDA, how many of y'all know what I'm talking about? All right, Quadja, I'm really proud of you, thanks. So, okay, EDA, let me explain it. First of all, EDA stands for Event-Driven Architecture. And I actually talk about this a little further down the road. But what it means is instead of me, let's say I get an order. And when I get an order, I need to let reporting know, I need to let fulfillment know, I need to let sales know. So if I'm the part of the application that takes orders, when it comes in, I can send I send a notification to fulfillment. I send a notification to reporting. All that effort and work is on me to send that out as that part of the application. Event-driven architecture says it's on them. I'm just going to send out, as the person who gets the order, I'm just going to send out an event. And we're not going to get deep technical on that. In the Ask the Speaker, I'm glad to expand on this. But that event and all those other services, if they want to know about it, then they'll subscribe to that event. They'll subscribe to either a topic or something on the bus. So now instead of our application making repeated API calls to each other, I'm just kicking out an event onto a bus, let's say, and then if someone needs to know, they'll pick up that event and react to it. Okay, so let me even simplify that more. This is how I define EDA. You ready? This is very technical, so I expect you to take notes on this. Here we go. Here's EDA. Something happens, and we react. Do you want me to do it again? Okay, I'll do it again. You look confused. All right. Something happens, and we react. I didn't see anybody write that down, but that's okay. But that's the basis of event-driven architecture. Yes, that's massively simplified, but that's kind of this idea of, rather than I don't have to communicate and tell everybody what's going on, I just need to kick out an event, and then someone could do that. And we can get more into that. This isn't an EDA session, but that's important to understand, because here's an interesting thing. Not all EDA architecture is serverless, but all serverless is EDA. 99%. I already see Alex thinking. Most serverless is event-driven, so it's important to understand. All right, so as we jump into this, the second trend that we see a lot of is configuration over code. Now, I've already hinted at this somewhat, but if you think about when I'm doing services, when I have a pub sub service, or I have an event bridge, or bus service, or topic, things like that, I configure them to do several things. One, to take and, to handle whatever its primary core purpose is. Two, to handle errors. Three, to handle dead letters, like things, something that's gone bad, it can drop it in a queue. So what I've done here is I can kind of pull a lot of that off. So where we used to build these monolithic Lambda functions that handled in our code, because we're developers and we code for everything, in our code we were handling event bus, we were handling queuing, we were doing orchestration, pub sub, so on and so forth, and you see that. But in reality, I can pull most of that out of my code and run it in a service. And I simply configure the service to handle this. Now, I'm not against code. I believe wholeheartedly in code and the massive importance of code, but why code for something that's not going to make you money, right? If you're building applications, you want to concentrate on the core services. You want to concentrate on what's really important. I just realized they're recording and I'm walking in and out of the camera, so I apologize. All right, so this idea of I'm not going to code, I'm going to configure, and then I can get to my business logic as fast as I can. Now, the interesting thing here, you see we got this error handling. We code for error handling, don't we? Something goes wrong, we got to catch it, we got to do something. But what's interesting is all these services, or most of them, have the ability to handle error handling right inside of them. So you configure for error handling. Now, does that remove all your code? No. But it greatly reduces the amount of code you have to write and increases your focus on the code you should be writing. Now, one example of this is a service we have called step functions. Has anybody used step functions so far? All right, good, a lot of you. Do you love it? is super cool. Step functions is an orchestration tool that allows you to orchestrate the way your code flows. The other thing it does is it allows you to directly integrate with services using the SDK. That's the software development kit. Now this is really cool and important because where we used to always use a Lambda function, we would invoke a Lambda function, it would use the software development kit, the SDK, in the code, and it would call a service and then respond to step functions. It makes that unnecessary. In this example here, this is actually an example from the Serverless First that you're seeing right over there. This is our order service here, and it handles, it says, hey, it reads directly from DynamoDB and it gets the shop status. And then it does some different things and it actually calls other step functions. But I didn't have to use a single Lambda function. If you're doing the workshop tomorrow, you'll get to build this. And it shows you how a lot of times I can configure an application and only use code for business logic. So there's configuration over code. A second example of this is API Gateway and direct integration with API Gateway. Has anybody ever done VTL? When I say VTL, okay, yeah, I don't blame you. Yeah, and do you love it, Sabarsky? Yeah, VTL is not for the faint of heart. That's the truth. VTL stands for Velocity Templating Language, and it's a templating language that allows you to transform requests. So if I have a request come in at my API Gateway endpoint, instead of having to have a Lambda route that, I can transform the request and talk directly to a data stream or a queue or DynamoDB. In fact, we have a URL shortener that we built internally at AWS, our team manages, that is just API Gateway and DynamoDB. And it's crazy fast and it's really solid. There's no code at all. Again, not for the faint of heart, but a really interesting project. So the next pattern that we're seeing a lot of, and this ties in with the EDA as well, is what we call asynchronous over synchronous. Asynchronous over synchronous. And the idea here is developers build, we think we need to send a request and wait, right? But the reality is clients don't like to wait, do they? They want instant answers or instant responses, right? The last thing is, let's say I'm paying for something with a credit card, I click pay, and the wheel spins forever. How long do your clients wait? Not very long, right? My mom doesn't wait long. She calls me within 3 seconds. Hey, this is broken. Did it charge my credit card twice? I'm good, Mom. Thanks for asking, right? People aren't patient. So we encourage, there's a lot of other reasons, but we encourage folks to go asynchronous whenever possible. Now, let me show you a pattern, and I love this pattern. I call it the storage first or persist first pattern. Normally, when we build, let's say we build an API for a website, okay, for a web development application. The standard pattern is your client makes a call to the API. API then routes it to the right compute. The compute runs all your business logic, and because we're developers, everything else, whatever you want to do. Then maybe it calls a database, and it comes back, and this is all done synchronously. And it's a viable pattern. It works. But what happens when, I'm going to try this here. What happens when it crashes here? What happens when that compute, something goes wrong? Well, you've lost the data, but therefore you've lost credibility with your customer, right? So you got to get on a phone and say, hey, guess what? We lost your information and your credit card number, but we think we have it right. Can you go ahead and give that to us again? And your customer's like, nah, I already bought it on Amazon, right? Y'all ever heard of an Amazon little startup in the US? And that's what they're going, yeah, I said, yeah, I've heard of it. And that's what's happening because they don't want to delay. So how do you kind of fix this? Well, the pattern that I often suggest is to actually go persistence first, meaning I'm going to have my API talk to something that's persistent. DynamoDB, SQS, SNS, and I can continue. Then I'm going to respond to the customer saying, we got your request, we'll get back to you when it's ready. And that's better than, is it working? Is it working? Is it working? They know you got the request. Then what I'm going to do is I'm going to talk to my compute and do whatever I need to do against that data. If my compute fails, I still have that data in my persistent layer, and I can try again. Right? So there's a huge reliability factor by reversing your process and persisting your data first and doing an asynchronous action against that data. Right? So this idea of asynchronous over synchronous becomes very, very powerful. And in EDA, which again, that's where we see a lot of people going, this is a very powerful pattern to act on. Now, I'm not saying never do synchronous, but I'm saying do synchronous only when you have to. All right, so the very last trend that we're seeing, well, it's not the last one, but another one, the very last one I'm going to tell you about, is what we call Serverless First. Now, I realize that these are not Japanese companies, and I'm sorry, but these are two companies in the U.S. Capital One is a huge financial firm, they're a bank. Liberty Mutual is an insurance company. Both of these companies have what's called a serverless first approach. And we're actually seeing this in a ton of companies. This is just the ones I'm listing. And the idea is we prototype everything on serverless. And you get a couple advantages. One, you can spin up, you can spin up a Lambda function in roughly 2 minutes. Depends on how fast you type and if you have thumbs or not. Right? So it actually depends on how fast you go. But I don't have to bring up a computer. I don't have to build all the infrastructure. I can prototype. Then what happens is if they decide, you know what, that's not a great fit for a Lambda function, then the next thing they'll do is they'll roll to containers. And they'll say, you know, that's the next, or EC2 or something like that. But always serverless first. And this is a trend we're seeing more and more and more of. So, just so you know. All right, so we've talked about kind of where serverless came up, a little bit of history. We've talked about some of the trends we're seeing globally. The next thing I want to tell you is I believe with all my heart, and you may just say, well, that's because you work for serverless, Eric. Nope, that's actually not true. I believe with all my heart that serverless is the future. I love the way Alex said this, and he explained, and we are seeing a lot of things like Memento. We'll talk about Memento and the green shirt, which is yellow. But they have built this amazing serverless technology on top of AWS, right? And we have other companies that are building, and what's happened is they're taking and using AWS primitives, the plumbing, and they're putting really nice paint on top. And it's third-party applications. And I love it. I'm a huge fan of that. Because at AWS, we do build phenomenal primitives. We build these beautiful pipes, right? So I think that honestly, I'm going down. I've broken this several times here. I think that honestly is where the future is headed, and you're going to see more and more. So there's 4 things that I'll call out and tell you why I think serverless is the future. The first is companies are embracing EDA. Companies are coming to us, and as I've said earlier, EDA, something happens, we respond. Serverless is perfect for event-driven architecture. Again, not all EDA is serverless, but all serverless is EDA. And it's built into that mindset. Amazon or at AWS, we didn't invent EDA. We didn't go, hey, we got this great idea, EDA. But we made it much easier for companies to do. We made it where they can come in and do EDA, because here's the truth. Distributed applications are hard. Distributed computing, distributed databases, things like that. It's hard. And so we've said we'll handle that heavy lifting, and then you can build EDA. And companies are embracing that to build systems. So that's reason number one. Reason number two, serverless containers. I talked about it earlier. I love this idea. In our communities, we have a lot of people saying, look, I'm only containers. I don't touch your serverless. Ew. Or we have serverless people going, I'm only serverless. Containers are to ship things in, right? And container people going, yeah. But the idea is culturally, we've had this battle going on. But the reality is, you're going to start seeing more and more of hybrid applications. So we've seen these applications that are only serverless, applications that are only containers, where really honestly, they're not thinking what's the right tool for the job. And that's what we're seeing, especially, I'm not talking to you, Siri, especially when you think about, when we bring in this extra compute, how much more can we build? And applications really get the best of both worlds here. And I'm going to show you an example from a real world application. We have to do this video processing, images, video, things like that. And we want to do it on FFmpeg. So we're actually doing it in Python with our own. And so we don't know how long the video or how big the image or things like that will be. So we need to look at it and evaluate it. Sometimes it's going to be too long for a Lambda function. Lambda function is great because it comes up, it does the work, and it goes away. And we can get into some parallel processing, and all that's good, and it scales out, it does all that. But if your video is 2 hours and we need to churn on that for longer than 15 minutes, or we need bigger CPUs, or vCPUs and memory, things like that, then Lambda's not the best fit here. So what do? So here's what we built. We built this step function that when the image is dropped into an S3 bucket, it actually triggers the step function. The step function comes up, and it evaluates the size of that. It may look at the folder or anything, but it evaluates the size or location, depending on how you want to do it. And then it says, oh, we need you to run in a Lambda function. So it kicks off a Lambda function comes up, does the work, responds to step functions, and says, hey, I'm done. But on bigger files, here's what's really cool. We can now invoke a container task on Fargate. We don't need the service. We don't need the Fargate's, when you build a container cluster, you have the cluster, then you have the service that manages all this stuff. We don't need that. The step functions acts as the service, and it says, here's the task definition. Run this application. And it takes a little longer to come up, anywhere from 10 to 15 seconds. It comes up, but it's asynchronous. Our customer's not waiting. We don't care. It comes up, it does the work, and then it goes away, and it lets step functions know. So in this world, I'm taking advantage of either serverless Lambda function or serverless containers. So I have real wide a range of compute power at my fingertips, and I believe this is the reason that we're going to see more and more companies adopting this. All right? So reason number 3, generative AI. What is a good presentation this year without the words generative AI in it? And that's all I have. Let's move on. No, I'm just kidding. I believe generative AI is going to be huge in the serverless space. And let me explain what I mean by that. In very basic terms, generative AI or AI in general comes down to 3 phases, right? So you're looking at design. Hey, I'm building my model. You're looking at training or fine-tuning, and you look at inference or consuming. But the interesting thing is, for 99% of us, and that's my data, I don't have any data to back that as far as the exact number, most developers will only consume AI technology. They might fine-tune as well, But most developers will be consuming this data. So here's the reality of that. That boils AI or generative AI down to an API endpoint, usually, right? You think of ChatGPT, you think of different services that are coming out. You're calling an endpoint to get a response. Here's my prompt, give me my data. That's what you're doing. So, like any other technology, how you choreograph that data and orchestrate the steps of how you build it is critical. What kind of process do you need to do to a bunch of data before you give it to a foundational model to summarize? What kind of, after you get it back, what are you going to do with it? Are you going to put it in a search model? Are you going to put something like that? And this is where serverless absolutely shines. With your compute power of Lambda functions or containers, or the orchestration of the data, this is where it shines. So this is where I think, because Gen AI, this is where it's gonna just shine. So again, 99% of us are just gonna be consuming this, and we're good. Got it. All right. So let me get to this is my last reason. And Alex touched a lot on this, and I really like what he had to say, and really I agree with what he said, and I'll expound a little bit. The fourth reason that's the future of serverless is the developer, or an improved developer experience. At AWS, we know, when you talk to developers, they love the idea of serverless. Hey, here's the idea. Or they see it in action. You look over here at Serverless Espresso, and you see it and go, man, that's cool. I love that. But it's getting from here to here that can be complex, right? It's that learning the developer model and understanding how to build serverless that gets complex. And so AWS, much like a lot of the third parties, we're turning our eye on the developer experience. How do we improve the developer experience? How do we take more cognitive load off our developers and let them get to their logic? Well, one is, if you're not familiar with AWS SAM or the CDK, some of the internal tools we have at AWS, where we have done a lot of work around what that developer experience looks like. And at AWS SAM, we take the approach of getting your code to the cloud as fast as possible, right? And so we use Accelerate, which syncs your Lambda function up very fast, or your step function or something like that. We've also built in Terraform and CDK support to that. With CDK, you have a thing called hot swap, where that automatically pushes things. And so the idea is, I save it, my Lambda function's up in the cloud, and I can run some end-to-end tests or do whatever. But there's an interesting evolution going on in some of our third parties as well. For example, there's a company called SST, which stands for Serverless Stack. So, what they've been able to do is they're able to allow you to debug a Lambda function in the cloud. So step debugging in the cloud. It's very cool. But there's this other idea that's coming out, and this is where I'm really going to focus on for a moment. And there's several companies in this space I'm going to highlight too. But there's this idea, or what I call, and they may debate this, but what I call infrastructure from code. Now that's different than infrastructure as code, right? So the idea here is I can code, and my infrastructure is implied from that code. And two big players in this are a company called Amped, GetAmped. You can go to getamp.com to see that. In fact, they just did their launch, and you may hear more about that later. They're doing some great things. And another company called winglang.io. And I thought it'd be interesting to kind of show you an example of what I mean. So, and no preference in either way, it's just the one I'm choosing to show. I'm going to show you what winglang looks like. Has anybody seen winglang? Okay, a couple of you, great, all righty. So let's jump into that real quick. So this is an idea. I'm not going to code in front of you because that's painful and nobody wants to watch that. But this is an idea of what a application looks like in Wing, and I'll explain this to you. The first and most critical thing is I'm going to bring the cloud. Now, winglang is an entirely new language. This isn't TypeScript. It exports to TypeScript, but it is a new language. So I'm going to bring the cloud. And then what I'm going to do, we'll go down to my Dice service here. And this application is one we did internally for fun, but it just rolls dice, and it has chances of failure and things like that. But the first thing I'm going to do here is you're going to see, hang on a sec, bring the cloud. I'm initializing some options. And then down here, I'm writing an error response. And I have a thing called in-flight, meaning this will be run in compute. In-flight means as it's going to be run in a compute option. Now, I've declared an API. So hang on, so right here. If you look here, I declared an API. It's let API equals new cloud API. I could also do new cloud bucket, new cloud table, new cloud whatever. And these are primitives based on, for the moment, AWS. This will also export to other clouds eventually, right? And so then I come down here and I've got this error response. Then in my API, now if you look, this looks very much like using an Express application. I'm just writing code. It looks like a monolithic application, right? And so I can go down here and here's my services in every function. And I won't walk through all the code. I'm glad to show this later. But down here, you can see where I actually instantiate the service and that runs it. So let me show you what that looks like. So if I say wing it main, I'm going to actually open a local terminal for testing. Okay. Now, if you've seen anything from me, I talk a lot about always test in the cloud. And I think that's critical because you're using services. But I love this approach because they're testing primitive actions that you can use. So you can develop all of this locally. You can actually see the application. Here's the different the gets and the posts and stuff like that. And if you're doing testing in serverless, this can run. I've actually written a series of tests real quick here. If I can pull this up, I'm going to hit play. Okay, and I'm now running tests locally, and I'm running a ton of tests to see if everything works out. So these tests are all declared in the code, and I can run this in my pipeline. Right? So the idea here is I code, let's go back to our code for a minute, and I can do a longer demo at some point in this, or I can point you to some stuff. But the idea is I'm building a monolithic app in front of me. But what happens when it's time to deploy? I don't want monolithic, I want distributed microservices. Winglang compiles to distributed microservices. It knows when I said a new API, it's going to use API Gateway on AWS. It knows when I say a table, which I do in there, it's going to use DynamoDB table. There's obviously opinionated. And it's going to create this infrastructure. And here's the fun thing is it will compile to Terraform or CloudFormation or CDK. You can give it different options, but it compiles out. So if you're looking, if you want that kind of experience of that monolithic idea deployed to a microservice, this is a great way to look at some of these services. The bottom line is companies like Wing and Amped, the Clotho, there's, again, like I said, there's several different ones. They came in and said, we want to paint better. Okay, again, that great analogy. We want to paint better. We love the AWS primitives, and SAM and CDK are doing some great things, but we want to even take that another step. As we enhance this development experience internally and third party, you're going to see, I truly believe you're going to see an explosion in serverless. Because selling the idea of this serverless compute, I don't have to sell it. I just tell people about it and they go, oh, that's cool. Then getting your hands on it, being able to build it, you're going to see more companies saying that's the way. They're going to turn to the serverless first method. So I encourage you, as you build your tool belt, check out some of these tools, talk to some of the folks that are in the room to build on that. With that, I'm going to say thank you very much. I believe that the future is serverless, and I'll answer any questions. And I appreciate it. I hope you enjoy the rest of the conference. We'll see you later.
Okay, thank you, Eric. So great explanation of serverless trend or something.
Oh,
Okay. では、また Ask the Speaker ブースにエリックいますので、気になることとかあれば聞いてください。で、今手を挙げてる人が翻訳とかも手伝ってくれますので、よろしくお願いします。じゃあ次のセッションですね。12時からまたやりますので、しばし10分ブレイキングタイムということで、よろしくお願いします。